You type git commit a dozen times a day, but what actually happens when you press enter? What if I told you that we could demystify version control forever by building our own modern version from scratch, right here using Node.js? This is Gitty. It is simplified, beautiful Git clone that we are going to build together. By the end of this video, you won't just use Git, you will finally understand how it works, and you will have an incredible project for your portfolio. Let's get started. Alright, here's our terminal. First things first, let's set up our Node.js project. We will create a directory called Git and initialize a package.json file. The most important thing here is setting type module, so we can use modern ES6 import and export syntax. Next, we need to install our dependencies. We will use Commander to build a professional command structure, Inquirer for beautiful interactive prompts, and Chuck and Figlet to give our CLI some style. Our project will have a main git.js file and a commands directory to keep our logic clean. Let's create those files now. In package.json, we will add a bean field. This is crucial. It tells Node that our git.js file is an executable command name git. Finally, in our main git.js file, we will set up the commander program. We will use Figlet to print a cool ASCII art header, define our version and description, and then register stops for our commands: init, add, and commit. With this skeleton in place, let's build our first command. Okay, let's tackle git init. The goal is to create a .git directory that will be our house, the entire version control database. This is the brain of the operation. Inside this file, we first import fs for file system operations, path for handling file paths correctly, and chuck for our colored console outputs. The function checks if .git directory already exists. If it does, we print an error and exit. We don't want to reinitialize an existing repository. If not, we create the main.git directory. Inside it, we create two crucial subdirectories, objects and refs. The objects directory will store our data, the contents of our file, and our commits. The refs directory will store pointers like our branches. Finally, we create the head file. This is one of the most important files. It tells Git what we currently have checked out. For a new repository, it will simply contain a reference to our main branch. Ref equals to refs/heads/main. It's not pointing to a commit yet, just to a location where the latest commit hash for main will be stored. Now, for git add, this command takes files from our working directory and prepares them for a commit. This preparation stage is called the index, or staging area. Git doesn't store duplicate copies of files. It's much smarter. It uses a process called content addressable storage. When we add a file, we read its contents, compress them, and create a unique SHA-1 hash from those contents. This hash acts as the file's unique ID in our database. So in our add function, we first locate our .git directory. We then read our index file. The index is just a simple JSON file that maps file names like index.js to their content hash. For each file the user wants to add, we read its contents, generate the SHA-1 hash using Node.js built-in crypto module, and we use that hash as the file name to save the content inside our .git/objects directory. This is known as a blob object. Then we update our index.json with the new file to hash mapping and write it back to the disk. This is the final and most exciting part. Git commit. This command takes everything in our staging area and creates a permanent timeless snapshot. A commit is itself just an object. It contains a few key pieces of information: the author, a commit message, a timestamp, and two critical pointers, a tree hash and a parent hash. First, we will use Inquirer to prompt the user for a commit message. This makes for a much nicer user experience. Next, we create the tree object. A tree represents the state of directory. We read our index file and build the tree object from its contents. We then hash these three objects to get a unique tree hash, and we save the tree to our objects directory. Now for the parent hash is what links commits together to form a history. We find the parent by reading the head file, which points to our current branch file. Example is like refs/heads/main. We read the branch file to get the hash of the last commit. Crucially, for the very first commit, the file won't exist. We handle this gracefully. If we can find a parent commit, we simply set parent to null. This is the definition of a root commit. With the tree hash, the parent hash, and the user's message, now we can construct our final commit object. We hash this object to get our new commit hash. We save it to the objects directory. The very last step is to update the branch pointer. We write our new commit hash into the refs/heads/main file. Now head points to the main and main points to our brand new commit. We have successfully updated our history. Finally, we delete the index file since its contents are now safely stored in a commit. And with that, our core logic is complete. Let's give it a final test drive. So first you have to write npm link in your terminal, and then write git init and git add git.js file and git commit. And you have to enter your message, and look at that, it works perfectly. We have a beautiful, interactive, and functional version control system built from scratch. We have gone from the command line all the way down to the file system to see how it all connects. Although you have just built your own modern Git client, you now understand the core concepts of blobs, trees, and commits. You know what the Git directory is actually for. This is a powerful piece of knowledge for any developer. If you got value out of this deep dive, please hit that like button and subscribe for more projects like this. Comment below with what feature we should add next to the Git. Thanks for watching and happy coding.